Well, did you enjoy that? A little sneak peek of what we're about to talk about tonight. Oh, excuse me, bit of a dry throat tonight. Okay, so for those of you who do Facebook and follow me on my engineering page, you'll know that just recently we've had a couple of Rotary Transformers in. That was one of them. And some people ask me, what are they? Now, I tried to explain in the past, but I thought I'd go into a little bit more depth this time. Okay, so I thought I'd give an explanation, or a bit of an explanation, as best I can, with the equipment I've got here. So for this explanation, I'll take it as read, right, that you know how magnetic induction works, magnetic fields, transformers, DC motors and generators, yeah. It's a big subject, and when I did my MEX course, we went to it in a lot of depth, talking about Fleming's left and right hand rules and all that kind of malarkey. But I'm not going to do that tonight. Otherwise, we'll still be here in the morning and we won't have got anywhere near the subject I want to talk about. So basically, what we're talking about here is voltage conversion. Yeah. In this instance, DC to DC, direct current. Now, nowadays, with modern technology, we've got things like buck converters, voltage converters, you know, the big things you find in caravans that take your 12-volt leisure battery up to 240 volts, that kind of thing. Nowadays, we have all this modern technology that uses a bucket load of components to change, say, from 12 volts to 240 volts. Now, back in the day, we didn't have all that. There were such things as DC amplifiers, but they're a whole different ball game. You Blue Silk guys might remember those. Yeah, I never understood how they worked, and they did try to teach us, but no, it just made no sense to me. But slight digression there. So, Rotary Transformers. Now, the one we're going to talk about tonight is from a TR 1196. Which is a transmitter, a 4-5 channel transmitter receiver, out of which was used in small aircraft like Spitfires, Hurricanes, Avroansons, that kind of thing. I'll put a picture up about there, which will possibly make me disappear off the screen, which will possibly be a bonus for you all. Okay, so it's a simple-ish radio set for small aircraft. But of course the problem is, all aircraft, or all the aircraft at the time, only had DC generation on board, yeah, which was usually 12 or 20 volts in later years. Now these radio sets, because they've got valves or tubes for our overseas cousins, they require 6 volts, 6.5 volts to run the heater coils, to get the valves hot so that they work, and you need a HT, usually over 100 volts. In this instance, with this radio, it's 250. So we've got to produce from 24 volts, we've got to produce 6.5 and 250 volts DC. So this is DC to DC conversion, not using a transformer, or, well, not using a conventional transformer or anything like that. So how are we going to do it? Well, what we're going to use, we're going to go back to basics, if you like. Let me just move that out of the way. And so, what I'm going to describe now, let me just pick it up, is this thing here. Yeah, lovely, isn't it? It looks sort of steampunkish. It's very nice, very tidy, very clean. Hasn't seen a lot of use. So let's see how this, which is a rotary transformer, works. So, as we're talking about rotary things, we'll start with the basic motor. You're now going to see some crappy graphics, I'm afraid. I thought I'd be able to do it with holding the picture, but I thought this is the best way. So here we go, 1, 2, 3, crappy graphics, away we go. So we've got a basic DC motor, yeah? We've got an armature, which is a rotating bit, and a field coil, which is a bit that doesn't rotate. So if we now put 24 volts across them, that is going to spin, because it's a motor. Yeah, put voltage across the motor, it spins. Right, so now we've got rotary motion. Yeah? So what we'll do, we now need the generation side of it. So what we'll do is we'll add 2 more armatures, because we want 2 more voltage on 2 more output voltages, and we'll physically connect those to the motor. Yeah, so the motor driven. We'll use the same field coil, because we've already got one. Why do another one when that's producing a nice magnetic field for us? So we can use that. And so now, when we apply 24 volts to the motor, those armatures are going to turn as well. And what happens when you turn a coil of wire through a magnetic field? You get voltage generation, or current generation, call it what you will. And so what we have now, with all this rotating together in the same field coil, we now have our 6.5 volt output and our 250 volts. Easy peasy. Okay, yeah, makes sense, doesn't it? Have I lost anyone yet? Possibly. Right, so we're generating an output now. But if we've got 2 armatures connected, right, it's going to be a big old long thing, isn't it? So what we do, we wind them all together. Hence, we get a nice compact little unit like this. Yeah, all the coils are wound separately onto one single armature. They all spin together. Yeah, and from 24 volts, we can get, in this instance, 6 volts and 250. In others, those big ones that I had the other day, they gave out 2 voltages. One was a heater voltage, once again about 6 volts, but the other voltage was 1200 volts. It was quite a power. It was a big radio set these were powering. Yeah. And rotary transformers were found all over the place during the war, because tanks need radios. They're 12 volts, 24 volts. So they used a number 19 set. Yeah, it was a very good radio set. I had one of those when I was a spotty youth, learning all about being a radio amateur and all that lot. And that had a rotary transformer in it. I'd never seen one before. Yeah, and you couldn't Google in those days, so I had to go to the library into their reference section in Lincoln and look it up, find out what the hell it was, because I'd got no idea. This great big thing screaming away, sucking all the juice out of 2 car batteries. Once I found out, it kind of made sense. So yeah, they were used in all military vehicles of that time, used this kind of thing. If you had a valve radio and you had a 12 or 24 volt system, you had one of these. Yeah, we're spoilt today with transistors and that. It's very easy to run systems these days off low voltages, but they had no option. But this was known technology. Yeah, motors had been known about for years. Generators had been known about for years. You just marry the 2 together, and instead of making a huge lump with a big engine here and a big generator down the bottom, you wind it all together. You get a nice small bit of kit like this. So enough nonsense from me. Let's get out the bench power supply and a couple of voltmeters, and let's see it in action, shall we? Yeah, let's go do it. See you in a minute. Right, here's the setup we've got now. We've got rotary transformer, bench power supply, and 2 meters. This one's going to show 240, that one's going to show 6.5. So that's the motor end, yeah, with a 24 volt motor in there. This is a generator end. This is the 250 volt commutator, and that's a 6.5 volt commutator. Now you watch as I turn it on, this gauge will suddenly jump up and then it'll all drop back to about 2.5 amps. And these two gauges will slowly rise as the magnetic flux and the RPM builds up together. Yeah. So there we go. Straight DC to DC conversion. 24 volts to 250 volts. Okay, so we've got the usual, the more you drag out of it, the more we'll have to put in, up to a point. But yeah, and of course, remember we've got no load on this today. That would actually make a slight difference. But yeah, so this was the technology of the day. This is 1930s, 1940s technology, if not earlier. This would have been made mid-40s, I would think. Probably still runs, still works, still produces voltage. When I dragged this off the shelf, plugged it in, and it worked straight away. This is fantastic. I love this kind of thing, I really do. Yeah, it gets me all unnecessary, shall we say. So there we go. 250 volts or 6.5 volts from 24 DC conversion a la 1940s old school. Yeah. Right, I'm going to turn this off now, so watch. This will drop off very quickly because that's the power supply. You watch the other two decay slowly as the RPM runs down and therefore the magnetic flux slowly dissipates. Marvellous, eh? Marvellous. I love it. Right, so let's just finish off, shall we? Right, well, wasn't that something? Well, I think so anyway. Like I said, I like this kind of kit. It's really good. It's simple, it's basic, easy to understand. Well, for some of us, I might have lost some of you there with the, yeah, I mean, let's face it, if I'd have gone into how motors and generators works, I'd have definitely lost a lot of you. But yeah, this post-war, or rather pre-war, and the sort of 1970s, 1960s technology, we were still using these on Vulcans, by the way, in a similar form. So yeah, 1940s, 1930s, 1940s, 1950s, into the 1960s, until the invention of solid state voltage conversion, I suppose, it was still relevant. And they work a treat. They're dead simple. Mechanical, electromechanical, very little goes wrong with them. Yeah, marvellous. So, I hope you all enjoyed that. Something a little different. And so, yeah, so it's a toodaloo from me. We got Christmas coming up in a week or so. So, whether you celebrate Christmas or not, I don't know. And it's none of my business, to be quite honest. But as long as you get your family together or your friends together and you have a good time, let's face it, that's what it's all about. So you guys out there, stay cool. Do all the good stuff. Yeah, send me your comments because I like reading them. And if you've got any suggestions on what you'd like to see, if we've got it down the Heritage Centre, I'll do something about it. I'll put it in the back of the car, bring it up here, and we'll have a little video about it. Like I've said before, I don't have much chance down there to do filming now because some of the guys I work with, you don't want to be on camera. And it's only a small bay, so they end up on camera. So yeah, so it does make it difficult for me, which is why I bring this stuff home and do it at home. But anyway, I digress. So anyway, Merry Christmas, or whatever you call it. Yeah, I'm not going to say the HH word because I think that's a nonsense. Just have a good time. Yeah, party on, get down with it. Have your family round. A few drinks if you're that way inclined. Turkey if you're that way inclined. Personally, we have steak with Stilton sauce. But there you go. We are strange that way. It's a very strange house here. So So, yeah, cheerio, have fun. If the weather stays fine, out on your bikes. So until next time, folks, yeah, have a good time over Christmas and New Year. I might do one for Christmas, but I don't know. All depends if I can get the old grey matter working. So, yeah, so ta-ta for now. Have a good time, and I'll see you on the next one. Bye for now.